So what is a homologous series? Well, in this video I'm going to start looking at Unit 2 of National 5 Chemistry, which is called Nature's Chemistry, and it's all about chemicals and compounds that exist in the natural world around us and why we might be interested in their properties or their reactions or what we can do with them. And before we start talking about those specifically and the different types of chemicals that we can find, we first have to understand what is meant by this. What is a homologous series? So when we say this, we are talking about a family of compounds that have, firstly, the same general formula. So they all follow some kind of pattern in terms of how many atoms they have in their compounds. And they share similar chemical properties as well. So not the exact same chemical properties, but in general, they'll all perform the same types of reactions, and they'll all have certain properties that mean they react in a similar way. So to start looking at this in more detail, to give you an example, here are 3 compounds, okay? And I can tell you that these 3 compounds are all part of a particular homologous series, which I'm going to look at in more detail in the next video, but for just now, let's just explore what kind of things relate these compounds to one another. So straight away, you might be thinking, well, I can see a similarity between just these 3 words even before we start talking about any of the chemistry. And that might be the fact that they all end in the same 3 letters. So if I just read them out, methane, ethane, and propane, you'll notice that they all end in ane. And that is important because that indicates which homologous series, which family these compounds are actually from. But I'll talk about that more in a minute. Also relating these compounds is the fact that they're all insoluble in water. So that's a chemical property that they all share. They're commonly used as fuels. So again, going back to this idea of similar chemical properties, they all react in a similar way. We can burn them all to release energy to varying extents. But very importantly, they all follow the same general formula. So what do we mean by that? Well, to look at that, I first want to talk a wee bit more specifically about carbon and carbon chemistry. So what I'm going to do is I'm going to give the molecular formula for each of these compounds. So what does that mean? Well, the molecular formula just tells me how many atoms of each element are in a compound. So for example, in methane, I know that I have 1 carbon and I have 4 hydrogens. Now, why is that? That is because of where these elements exist in the periodic table. So what does that tell me? Well, carbon is in group 4 of the periodic table. So that tells me that an atom of carbon, when covalently bonding, has to have a valency of 4. Well, what does that mean? That means that on my carbon atom, there have to be 4 bonds. Now, they don't all necessarily have to be single lines, and as I say, we'll touch on that a little bit more in future videos. But whenever you see carbon in this topic, when you're talking about homologous series, I want you to think of the number 4. Because carbon has to be able to bond to 4 things or bond 4 times. In this case, bonding to 4 hydrogen atoms. So that's my methane. Now, if we wanted to come up with a general formula at this point, it'd be quite difficult because we've only got 1 compound, so we can't really see any pattern yet. Maybe we could have a guess. Maybe we could say, well, for every carbon, I need 4 hydrogens. Or for every carbon I have, add 4 hydrogens, or something like that. Or maybe something else entirely. We'll soon find out. So the molecular formula for ethane, then, is 2 carbons, C2, H6. So let's see what that looks like. So again, first thing I've done here is made sure that if I'm using carbon, it bonds 4 times. It has 4 lines coming off of it. and that gives me the correct valency of 4 for carbon. And then again, given that this homologous series just has hydrogens in it as well as carbons, I will now fill in those hydrogens. So I wonder, can we see a general formula yet? Can we see what links this formula here and this formula here? Well, it's not quite that we're timesing however many carbons we have by 4, like it is in this one, because that wouldn't give us 6 here, it would give us 8, so it can't be that. What about our second idea that we had, where we have 1 carbon and we add 4 hydrogens for every carbon we have? That doesn't quite work either, so it must be something else. Well, maybe if we look at propane and have a third entry in this series, we might be able to figure it out. So propane has a third carbon and 8 hydrogens. So, again, carbon has to bond to 4 things, and each of those things, each of those elements in this case, has to be hydrogen. Okay. So hopefully now, the general formula that I'm looking for that makes these things part of a homologous series, that makes them part of the same family, should be a bit more obvious. So what we're in fact doing is we're saying, for every carbon that we have, let's just call that N for just now, that just means a whole number, so 1, 2, 3, 4 or above. For every 1 or every N carbon I have to times the number of hydrogens by 2 and then add 2 extra. Okay, so let's have a look at that. Does that work for our first entry? Does it work for methane? Well, I have N carbons, I have 1 carbon. So if I put 1 in here, that tells me I need to times that 1 by 2, which would give me 2, and then add on another 2, which would give me 4. 1, 2, 3, 4. So that one works. What about this one? Well, in this case, my N is 2, because I have 2 carbons. And then what did we have to do to N? We have to times it by 2, and then add another 2. So 2 times 2 is 4, and then add another 2 is 6. So that one works too. And then of course, propane also works. C3, so N is 3, times N by 2, 3 times 2, which is 6. Add 2, which gives me 8. So that works too. So this is our general formula. And it's called a general formula because all the entries, all the compounds in this homologous series follow this formula. So it can be generalized for the entire homologous series. And that's important because it can help us identify which compounds are part of this series. Now what I should say is that this particular series, or the start of this particular series, is called the alkanes. Now they have a set of chemical properties and this specific general formula that I'm going to look at in a little bit more detail in the next video. But for just now, what do we need to know? Well, a homologous series is a family of compounds that have similar chemical properties and follow this general formula. They may have other properties that they share, physical properties, chemical properties, but the main thing at National 5 that we are interested in looking at is identifying these compounds as being part of the same series by identifying their general formula.